Hello friends, welcome to my channel. After watching this video, you should have the clear distinction between the Fleming's left and right hand rule. That is, what is these rules and where to use these rules.
Okay, let's begin. What is the significant similarities between these two rules? That is Fleming's right hand rule and Fleming's left hand rule. Here in these two rules, they uses the same fingers to obtain the direction of motion, magnetic field and electric current. This is the main similarity between these two rules. The difference is one uses our right hand and the other one uses the left hand, and the scenario in which these two are applied. Here it is I have written as EMI, that is electromagnetic induction. Fleming's right hand rule is used in situation where there is an electromagnetic induction. All of you know that electromagnetic induction is the case where we obtain an EMF when there is a significant change in the flux linkage. And Fleming's left hand rule, that is used in the scenarios where there is a current carrying conductor in a magnetic field. In order to examine these two, let us consider a simple problem. Before beginning this, I just give you a notation that you can remember while using your thumbs. That is, here I just give you a simple notation, that is father, mother, child. It is in the order thumb, forefinger, middle finger. So father means the force or the direction of motion of conductor, direction of motion of conductor. And M, magnetic field. And C, current. So here when you are placing your right hand in such a way that these three fingers are mutually perpendicular, then father means the thumb, here it gives the direction, and mother, which is the forefinger, which gives the direction of magnetic field, and child, that is the middle finger, which gives the direction of current. In this way you can easily remember these things. So here I just going to explain a problem which is asked in SSLC Kerala 2020 physics. Here a conductor AB is placed in a magnetic field as shown in the figure, and there is two parts where you have to apply both Fleming's right hand rule and left hand rule. So after solving this question, you can have a clear-cut idea where to use these rules. So let us move to the first A part of this question. If you are moving the conductor outward, then what will be the direction of current in the conductor? So while examining the given figure, there will be a magnet. There is a magnet, U magnet, and a conductor which is suspended by using some arrangement. Okay, let's move to the first part, that is A part of this given question. It is, if you are moving the conductor outward, then what will be the direction of current in the conductor? So here we are moving this conductor AB outward, then definitely it cut the magnetic field. As we know that the magnetic field is in the direction north to south. So it will definitely cut the magnetic field, and hence there will be an EMF will be induced. So there will be an electromagnetic induction. Okay, here there will be an electromagnetic induction. So in case of an electromagnetic induction, which rule we have to use? Fleming's right hand rule. So I just stretch my fingers in this mutually perpendicular direction, and here the force. Yes, here we are in the conductor AB is moved outward, that is why I placed my thumb in this direction, and here it is magnetic field. As we know that the magnetic field is from north to south, and where is the direct, what is the direction of current? It indicates the direction of current. It is from this, examining this figure and my middle finger, you can easily infer that the direction of current is B to A. Very simple, right? Okay, let's move to the B part of this question. If an electric current passes from A to B, then in which direction the conductor will move? So here we have a current carrying conductor in a magnetic field. In such a scenario, we have to use Fleming's left hand rule. That is, when there is a current carrying conductor in a magnetic field, we have to use Fleming's left hand rule. So I just take my left hand in such a way that all these three fingers are in mutually perpendicular direction. All other things remain same except I changed my hand. So by examining this question, here we have the direction of current is from A to B, right? A to B. So I place A to B. This is my direction of current. And I have the direction of magnetic field from north to south. So this is the magnetic field. It is from north to south. I cannot hold my fingers in a proper way. That is why you may have some improper view. So I could do the maximum possible way I can. That is here. Okay, A to B, right? The current direction of current, and here it is north to south. That is direction of magnetic field. Then definitely this will be the direction of motion. So this will be definitely this will be the direction of motion, right? Direction of motion. So this is A to B, direction of current, north to south, direction of magnetic field, and this is direction of motion or force, which is in this direction, though therefore in this direction, right? That is outward the magnet. So thank you for watching my video. For any queries, please comment on the comment box.